Hello everyone, welcome back to my YouTube channel. In this video, I will introduce you to a circuit that measures L, R, C components with very fast display results and very accurate results. The circuit is developed based on the product of a Russian author. The circuit uses common components with the display clearly shown on the LCD screen. I believe that, with this product, it will help you a lot in your electronic DIY work. Thank you to the author for sharing this circuit. Some information about the circuit. For non-polarized capacitors, the circuit can measure from picofarad to microfarad with an accuracy of 1%. For polarized electrolytic capacitors, the circuit can measure from 100 nanofarad to 100,000 microfarad with an accuracy of 5%. For inductors, the circuit can measure from 10 nanohenry to 20 henry. For resistors, the circuit can measure 1 milliohm to 0.5 ohm with an accuracy of 5%. As you can see, I have used the circuit to measure non-polarized capacitors with very small capacitance values. This is very necessary. Think in R/C oscillating circuits. If the capacitance is not correct, the frequency in the circuit will be changed. The circuit has a function to change the measuring scale to suit each type of component. There is a calibration button next to it to ensure the device has been returned to zero value before measuring a new component. For polarized capacitors, in addition to the capacity value of the capacitor, there is also the internal resistance value ESR of the capacitor. The equivalent series resistance SR, also known as the internal resistance, is the value that represents the loss of useful energy in a simple electronic circuit consisting of a resistor and an ideal perfect capacitance. The smaller the ESR value, the better the capacitor. You can see, some electrolytic capacitors, the value on the label is much larger than the actual value. This is bad if you do not have a measuring device to verify. I am measuring the resistor values. You can see that their values are very small. With normal VOMs, we cannot measure these values. To get accurate measurement results, we need to calibrate the circuit by clamping the measuring probes together. Then press the calibration button. The value will return to zero to ensure accurate measurement results. A very valuable feature of this circuit is the ability to measure inductance values. This feature is only available on expensive electric meters. With this circuit, you can easily do that. The circuit displays the inductance value immediately without having to wait. It also has a short circuit detection function. When short-circuited, the inductance value will return to zero. I will guide you in detail how to do it after some introductory information about my partner JLCPCB. This video is sponsored by JLCPCB. JLCPCB is the full-service electronic manufacturer. JLCPCB's innovative one-stop service model makes production highly efficient by tightly integrating EDA software, PCB fabrication, parts purchase, stencil cutting, and SMT assembly. Black Friday 2020 for deals from November 25th to December 15th. JLCPCB is offering massive discounts and incredible giveaways during its Black Friday sale. Enjoy savings of up to $252 and a guaranteed prize with every entry, including a chance to win a Samsung 55 gaming monitor or Genio drone. Now visit the link below description for exclusive deals and a chance to win amazing prizes. This is a result after 1 week. The box and circuit are from JLCPCB. The circuit is drawn on a board. You can easily create it manually. It is best to use the file I shared to order the circuit from JLCPCB. This will help the circuit not be noisy. Here is a schematic diagram of the circuit with capacitors and inductors marked as important components. Use the best components you have to ensure the best performance of the circuit. The circuit uses a 12-volt power source After passing through the 7805 voltage regulator IC, the voltage supplied to the microcontroller is 5 volts. The circuit uses LCD 16:0 to screen. This is a common LCD screen. You can easily buy it. The relays used are all 12-volt type. This is the circuit after completing components such as resistors, capacitors, relays. The inductor, I used the blue core as shown in the picture. Using 1 mm diameter wire wound 35 turns, you can use a ready-made inductor. I used a cable to extend the LCD screen. In addition, I also used a 12-volt battery to supply the circuit. I have finished the tutorial. Wish you success. Don't forget to like, share, subscribe my channel. I'll see you next time.